In this video, we'll go over box and whisker plots and the normal curve. The two things that we're going to cover is how is the 5-number summary reflected in a box plot, and we'll discuss how to make that box plot. And secondly, what is a standard normal distribution, and how do we use it to find probability? When we talk about a 5-number summary, we're actually talking about the minimum, the first quartile, the median, the second quartile, the third quartile, and the maximum. We'll look at specifically how to make that box and whisker plot, but one thing to keep in mind is that if you're making 2 or more box plots when you need to compare data, make sure that you use the same scale so that the comparisons can be easily made. So the following are the duration times in minutes of all the missions flown by the Space Shuttle Challenger. What I want to do is go ahead and create the 5-number summary, which you can do by hand, but you can also use with a graphing calculator. If you're going to do this by hand, you need the data to be ordered from least to greatest, and that's already been done for you. So I'm going to go ahead and circle the minimum and the maximum values, and then we need to go ahead and find the median. If we look, we have 9 pieces of data, which is going to make the 5th piece of data the median. And how I came upon that so quickly was just by taking the number of pieces of data n, adding 1 to it, and dividing by 2. So I'm going to count over 5 and circle the median, which is 10,089. So that's what divides the data in half. Now we need to figure out what divides the bottom half in half. To determine that, I can manually cross out and see that the median of the lower half is going to fall between those two numbers, and the median of the upper half is going to fall between these two numbers. And to find that, I'll average the two numbers that it falls between. That's how we would do this by hand. Of course, we can also use technology to find the 5-number summary. In order to find the 5-number summary using your graphing calculator, you're first going to hit the Stat button. It's going to default so that Edit is highlighted, so you'll hit Enter, and you're going to enter that data into L1. We've done this before when we've done the scatter plots. Then you're going to go to Stat, you're going to arrow over to Calculate, and you're going to hit the default, which is number 1. You're going to need to hit Enter and scroll down through that data using your down arrow, and you will see minimum, Q1, MED, Q3, and maximum all come up. Let's suppose that you have found your 5-number summary, and the results are what you see listed here. To draw your box plot, you're going to create a number line. So the easiest way to make this box plot is go ahead and put dots over top of each one of these parts here. So we've got something at 1, something at 4, something at 5, something at 7.5, and something at 9. Your box is actually going to go around Q1 and Q3, and we're going to draw a line down the center at the median, and then you're just going to draw lines out to both your min and your max. Let's switch gears and talk about the z-scores of normal distributions. A standard normal distribution is normal with a mean of 0 and a standard deviation of 1. And what's important to notice is that the total area under this curve here, if we were going to find that area, is known to equal 1. When we're finding the probability underneath of that curve, though, we're not going to be finding the area of the entire thing. We're going to be asked to find areas under the curve either to the right of a number, to the left of a number, or in between two numbers. To do that, you can use technology or Table A-2 of Appendix A. Table A-2 is going to be 2 pages, with the left page being used for negative z-scores and the right page used for positive ones. Each value of the table represents the cumulative area from the left to the vertical boundary that's given. Let's see how we would use this. Suppose a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis, a disease causing bones to become pretty fragile and likely to break. The result of a bone density test is commonly measured as a z-score. The population of z-scores we know to be normally distributed with a mean of 0 and a standard deviation of 1. A randomly selected adult undergoes a bone density test. Find the probability that the result is less than 1.27. So what you're going to do is you're going to plot this graph. We're already giving the z-score. There's 0. We're going to put 1, 2, and 3 on our number line. And I'm going to put 1.27 as a vertical line approximately here. And I want to know the probability that it's less than 1.27, or find the area of the curve to the left of 1.27. The table A-2 we're going to read by going down on the left to 1.2 and then going across until we also reach the 0.07. That's going to give us the 1.27. And we can see here that the number that goes with that is 0.8980. Since this is cumulative area from the left and we're looking for a less than, that's the number that we want. What if the problem wasn't looking at area to the left, and what if we were interested in probability or area to the right? So I want to know the probability that a person randomly selected has the result above -1. So there's my 0, -1, -2, -3. And I'm going to put my vertical mark coming down at -1, and I want this part here that you also see in the picture above highlighted in red. But remember, the table is going to give me area to the left. So when I look up -1, it's going to give me 0.1587. Since I know this entire thing adds to 1, I can subtract that number from 1 to get the area to the right, which is what we actually are interested in. Other times we have to find the area between two numbers. So if I want to find the area between -2.5 and -1, the first thing that I'm going to have to look up in the chart is the area to the left of -1. And you can see here that it's found to be 0.1587. I need to subtract out the area to the left of the -2.5 because I don't want that piece. And what will be remaining is the area that we're actually interested in. Of course, as with everything with statistics, this can be done using your graphing calculator. You'll hit second and then VARS button, which is just to the left of your clear button. You're going to select normal CDF. You need to enter the left boundary and then a comma and then the right boundary. So if you're looking for the area between two values, both of those values will be given, and it will find the area between them for you without having to use the table. If I'm looking and there's no lower boundary, so I'm looking to the left of a number and it goes to -infinity, use a very large negative number as your left boundary, like -1 million. And likewise, if there's no upper boundary, so if I'm trying to find the probability that something is greater than 2, I'll do normal CDF, I'll enter 2, and then I'll enter a really large positive number, like 1,000,000. And it'll give me a close enough approximation for that area. Sometimes you'll be asked to work backwards. You'll be given the probability, and you'll be asked to find the z-value that goes with it. To do this, I want you to use technology. You're going to hit second and VARS, and then go to inverse norm. All you have to do is enter the total area to the left of the z-score and hit enter, and it'll give you the z-score that corresponds with it. The problems that we've looked at up to this point have actually been given in terms of z. But sometimes you may have to convert a value x to a value z in order to get started. To do that, you're going to take your x value and subtract the mean from it, and divide that answer by the standard deviation. You always round your answer to 2 decimal places because that's what you're going to use in your table. Let's actually do this problem so that it makes a little bit more sense. Suppose that the social organization Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have normally distributed heights, with a mean of 63.8 and a standard deviation of 2.6, find the percentage of women who satisfy that height requirement. So we're trying to find the probability that x is greater than or equal to 70. 70 is not a z-value though, so we need to convert it, and that's where we use that formula. So we're going to take 70 and subtract 63.8 and divide that answer by 2.6. That will give us our z. When you get that answer in your calculator, you should find that z is approximately 2.38. So you can see that I've already drawn and shaded what we're looking for. We're looking for greater than 2.38. So we're going to look up 2.38 in the table. That's going to give us what's in red over here, so we'll need to subtract that answer from 1. When you look up 2.38 in the table, you'll end up with a value of 0.9913. You need to subtract that value from 1, and your resulting answer is 0.0087. We can change that number to a percent since it's asking for the percentage by sliding the decimal point over 2, so 0.87% of the women satisfy that height requirement. When people design things, they typically design something that will accommodate 95% of the population. So suppose we're designing an aircraft ceiling height, and we want an aircraft ceiling height that 95% of men will be able to stand under without bumping their heads. Assume that the heights are normally distributed with a mean of 69.5 and a standard deviation of 2.4. What aircraft ceiling height will allow 95% of the men to stand without bumping their heads? This is one of those backward problems where you need to use the inverse norm function of your calculator. So remember, you're going to go to second and then vars, and then you're going to go down to number 3, which is inverse norm. You need to enter 3 pieces of data. The first piece is going to be the percentage, but you're going to put it in as a decimal, comma. The second piece of data that you need to put in is going to be your mean. And then the last piece of data that you're going to put in is going to be the standard deviation. When you do that, you end up with a value of 73.4476487. So we know that we need that height to be about 73.4. I'm going to have you do one on your own, and I want you to input your final answer to the screen to the right, but I want to talk you through it first. A water taxi sank in Baltimore's Inner Harbor, and an investigation revealed that the safe passenger load for water taxis was 3,500 pounds. It was noted that the mean weight of a passenger was 140 pounds. If we assume the worst-case scenario that all the passengers are adult men, and we're going to assume that the weights of the men are normally distributed with a mean of 182.9 pounds and a standard deviation of 40.8 pounds, what's the probability that a man selected will weigh less than 174 pounds? The first thing you're going to have to do is convert this 174 pounds into a z-value, because that's your x. So you're going to take 174, you're going to subtract the mean, which is the 182.9, and divide it by the standard deviation, which is 40.8. The 3,500 pounds that you see above is extra. Also extra is the mean weight of 140, because the data that we're looking at is data just about men. So go ahead and find your z-value and enter it to the right. So you're trying to find the probability that z is less than whatever value you've just entered to the right. So you can either use your table to look that up or use your graphing calculator using the normal CDF function. When you have that, go ahead and enter that probability as a decimal rounded to 2 decimal places to the right. I want you now to do your assignment on box plots and the normal curve.